Have you ever wondered what exists in the vast emptiness surrounding the International Space Station? Today we're embarking on an incredible journey to explore the mysterious layers of space both above and below humanity's orbital outpost. We'll discover why the ISS sits exactly where it does, what dangers lurk in the spaces around it, and why venturing too high or too low could spell disaster for the astronauts aboard. The International Space Station orbits at approximately 250 miles above Earth's surface. That's roughly the distance from New York to Washington, D.C., except going straight up. But this specific altitude isn't random. It's a carefully calculated sweet spot that took decades of engineering expertise to determine. Below the station lies a dangerous realm where Earth's atmosphere fights back against anything trying to orbit. Above it? Well, that's where things get even more fascinating and terrifying. If you're enjoying this cosmic journey already, go ahead and give this video a like. It really helps us create more space content for curious minds like yours. Let's start by understanding exactly where the ISS sits in Earth's atmospheric layers. The station orbits in what scientists call the thermosphere, a region that extends from about 50 miles to 440 miles above Earth's surface. But here's what's fascinating. Even though it's called the thermosphere because temperatures can reach 3,600 degrees Fahrenheit, you'd actually freeze to death if you stepped outside without a spacesuit. How is that possible? It's because the air molecules are so sparse that they can't transfer heat effectively. Imagine being in a room with only 3 or 4 super hot ping pong balls bouncing around. They might be scorching, but with so few of them, you'd barely feel any warmth. Speaking of dropping too low, the ISS actually falls toward Earth constantly. Yes, you heard that right. It's perpetually falling, but it's also moving sideways so fast, about 17,500 miles per hour, that it keeps missing Earth. Think of it like throwing a baseball so hard that by the time gravity pulls it down to where Earth's surface should be, the planet's curve has fallen away beneath it. That's essentially what orbit is, falling around Earth rather than into it. What lies directly below the ISS? The answer is more complex than you might think. Immediately below, starting around 50 miles down, we enter the mesosphere, the coldest layer of Earth's atmosphere where temperatures plummet to minus 130 degrees Fahrenheit. This is where most meteors burn up, creating those stunning shooting stars we see from Earth. Every day, the ISS passes over this cosmic graveyard where space rocks meet their fiery end, protected by the very atmosphere that would doom the station if it dropped too low. Below the mesosphere lies the stratosphere, extending from about 7 to 30 miles up. This is where commercial airplanes cruise, safely below the harsh radiation of space but high enough to avoid most weather. If the ISS were to somehow descend to this level, it wouldn't gracefully glide like an airplane. The station would become a 450-ton fireball, compressed and heated by atmospheric friction until nothing remained but scattered debris. It's a sobering reminder of how precisely balanced our presence in space really is. But what about above the station? This is where things get truly mind-bending. Directly above the ISS begins what scientists call the exosphere, Earth's outermost atmospheric layer that gradually fades into the vacuum of space. The exosphere extends from about 440 miles to an astounding 6,200 miles above Earth. That's nearly the diameter of Earth itself. Up here, individual atoms and molecules can travel hundreds of miles without bumping into each other. It's like having a dance floor the size of Texas with only 2 dancers on it. As we climb higher above the ISS, we encounter the Van Allen radiation belts, 2 donut-shaped zones of charged particles trapped by Earth's magnetic field. The inner belt starts around 600 miles up, while the outer belt extends from about 80,400 to 36,000 miles above Earth. These belts are so radioactive that astronauts passing through them during the Apollo missions saw flashes of light with their eyes closed, cosmic rays literally zipping through their eyeballs. The ISS orbits safely below these hazardous zones, protecting its crew from radiation doses that would be lethal with prolonged exposure. Would you be willing to live in this narrow band of survivable space, knowing what lurks above and below? Here's something that might surprise you. There are actually other spacecraft orbiting below the ISS. Military reconnaissance satellites, Earth observation platforms, and even some CubeSats operate at altitudes between 100 and 200 miles. But these lower orbits come with a price. Atmospheric drag is so strong down there that satellites need frequent boosts to maintain altitude, or they'll re-enter Earth's atmosphere within weeks or months. The ISS itself requires regular reboosts about once a month, using either its own thrusters or those of visiting spacecraft. Let's talk numbers for perspective. If Earth were the size of a basketball, the ISS would orbit just 7 millimeters above its surface, less than the width of a pencil. The atmosphere we breathe would be thinner than a sheet of paper wrapped around that basketball. When you see it this way, you realize how incredibly thin the margin is between the safety of Earth and the deadly vacuum of space. Above the ISS, in what's called medium Earth orbit, starting around 1,200 miles up, we find the GPS satellites that help you navigate to your favorite coffee shop. These satellites orbit in a special zone where they complete exactly 2 orbits for every 1 rotation of Earth, allowing them to provide consistent coverage. But operating at this altitude means dealing with increased radiation exposure and the occasional impact from micrometeoroids traveling at speeds up to 40,000 miles per hour. Imagine a grain of sand hitting with the force of a hand grenade. Sometimes, astronauts aboard the ISS report a profound psychological effect called the overview effect. Looking down at Earth without borders, seeing the thin, fragile atmosphere that protects all life, they experience a cognitive shift. Looking up into the infinite blackness, knowing that everything and everyone they've ever known exists on that blue marble below, creates a sense of unity and responsibility that many describe as life-changing. The space between the ISS and these higher satellites isn't empty. It's filled with space debris. There are currently over 34,000 tracked pieces of junk, larger than 10 centimeters orbiting Earth, and millions of smaller fragments. The ISS has to perform debris avoidance maneuvers several times each year when tracking stations detect a potential collision. In 2021 alone, the station had to dodge space junk 3 times. Each piece of debris is a bullet-sized reminder of our responsibilities as a spacefaring species. But the ISS can't venture higher to get a better view. Above 500 miles, the radiation environment becomes increasingly hostile. Solar flares can send waves of charged particles screaming through space at millions of miles per hour. Without Earth's magnetic field and atmosphere providing protection, astronauts would receive radiation doses equivalent to thousands of chest X-rays in a matter of hours. The ISS has a special shielded area where crew members shelter during severe solar storms, but even this protection has limits. What would you feel floating in that metal cocoon, suspended between Earth and the cosmos? The region directly above the ISS is also home to some spectacular phenomena. The aurora borealis and aurora australis, the northern and southern lights, often dance below the station at altitudes of 60 to 200 miles. Astronauts get a view that no Earthbound observer can match, looking down on these shimmering curtains of green, red, and blue light as charged particles from the sun collide with our atmosphere. It's like watching Earth put on a light show just for them. Have you ever wondered why we don't just put the ISS higher to avoid atmospheric drag entirely? The answer involves a delicate balance of factors. Higher orbits mean more radiation exposure, greater difficulty reaching the station with supply missions, and increased fuel requirements for visiting spacecraft. Every additional mile of altitude costs millions of dollars in extra rocket fuel over the station's lifetime. The current altitude represents an optimization problem solved by thousands of engineers. High enough to minimize atmospheric drag, low enough to remain accessible and somewhat protected from radiation. It's humbling to realize that despite all our technological achievements, we're still bound to this narrow shell around Earth. We're like deep-sea creatures that can only survive in a specific pressure range. Venture too high or too low, and the environment becomes lethal. The ISS represents the absolute edge of where humans can live long-term with our current technology. Temperature management presents another fascinating challenge based on the station's position. The side facing the sun can reach 250 degrees Fahrenheit, while the side in Earth's shadow drops to minus 250 degrees. That's a 500-degree temperature swing every 90 minutes as the station orbits Earth. The ISS uses a complex system of radiators, heaters, and insulation to maintain a comfortable 70-degree environment inside. It's like having a house where one wall faces a blast furnace while the opposite wall touches a glacier, and somehow keeping your living room at perfect room temperature. Looking below the ISS at night reveals one of the most beautiful sights in space, Earth's air glow. This faint layer of light, caused by chemical reactions in the upper atmosphere, creates a gossamer thin green and gold band wrapping around our planet. From the ISS, it looks like Earth is wearing a delicate crown of light. Astronauts often describe it as one of the most ethereal and beautiful phenomena they witness, a reminder that even Earth's atmosphere is alive with complex chemistry and physics. What happens to the ISS when it finally reaches the end of its operational life? The space below the ISS is becoming increasingly crowded with mega-constellations of satellites. Companies like SpaceX, Amazon, and OneWeb are launching thousands of satellites into orbits between 200 and 750 miles high. This growing traffic increases collision risks and creates challenges for astronomical observations from Earth. The ISS must now navigate through this increasingly dense shell of human technology, like a ship sailing through waters that grow more crowded each year. The space above and below the ISS teaches us something profound about human ambition. We found this impossibly thin slice of space where we can survive, and we've not just survived there, we've thrived. For over 2 decades, humans have continuously occupied this narrow band between Earth and the cosmos, conducting experiments, making discoveries, and proving that our species can adapt to the most hostile environment imaginable. But the legacy of the ISS's unique position won't end there. Future space stations are already being planned, some at similar altitudes, others venturing higher or lower based on their specific missions. Commercial space stations might orbit lower for easier tourist access, while research stations could push higher to study radiation effects or test technologies for deep space missions. Current plans call for the station to be deliberately deorbited around 2031, brought down in a controlled descent to crash into the Pacific Ocean's Point Nemo, the spot on Earth furthest from any land. It will be a bittersweet moment, watching humanity's longest-occupied space habitat become a shooting star, returning to the planet it spent decades observing. But the legacy of the ISS's unique position won't end there. Future space stations are already being planned, some at similar altitudes, others venturing higher or lower based on their specific missions. Commercial space stations might orbit lower for easier tourist access, while research stations could push higher to study radiation effects or test technologies for deep space missions. The space above and below the ISS teaches us something profound about human ambition. We've found this impossibly thin slice of space where we can survive, and we've not just survived there, we've thrived. For over 2 decades, humans have continuously occupied this narrow band between Earth and the cosmos, conducting experiments, making discoveries, and proving that our species can adapt to the most hostile environment imaginable. Every 90 minutes, the ISS completes another orbit, passing over different parts of Earth, crossing from day to night and back again. Above it stretches the infinite cosmos, filled with radiation, debris, and wonders we're only beginning to understand. Below it lies the warm embrace of Earth's atmosphere, both a cushion and a barrier, protecting us while limiting our reach into the universe. Perhaps what's most remarkable about the ISS's position is how it perfectly captures humanity's current place in cosmic history. We're no longer completely earthbound, but we're not yet truly spacefaring. We exist in this transitional moment, reaching upward while still tethered to our home world, like a child taking their first tentative steps away from their parent. The next time you see the ISS passing overhead, that bright, steady light crossing the sky, remember that you're looking at humanity's foothold in the cosmos. You're seeing 6 people living in that narrow sweet spot between Earth and space, in a carefully maintained bubble of life surrounded by environments that would kill them in seconds. Understanding what lies above and below the ISS helps us appreciate the incredible achievement it represents. It's not just a laboratory or an observation post, it's a testament to human ingenuity, international cooperation, and our relentless desire to explore beyond our boundaries. The station exists in the only place it can exist, making the most of the harsh realities of orbital mechanics, radiation, and atmospheric drag. Thanks for joining me on this journey through the layers of space surrounding the International Space Station. The cosmos above and the atmosphere below remind us that space exploration isn't about conquering the universe, it's about finding our place within it. Share your thoughts in the comments below. Would you want to visit the ISS, knowing what surrounds it? What aspects of life in that narrow orbital band fascinate or frighten you most? Thanks for watching, and if you want more space adventures exploring the boundaries of human endurance and ingenuity, hit that subscribe button. Next time, we'll explore what it actually feels like to live inside the ISS, from the strange sounds that keep astronauts awake to the unexpected smells of space itself. Until then, keep looking up, and remember that right now as you watch this, there are humans living in that impossible space between Earth and the stars.